To accomplish the feats of futuristic magic, pay close attention to this tape to acquire the tools you will need to manage information. Welcome to Dallas Public Schools Algebra 1 program, Algebra Discovered. This video will address gathering, displaying, and analyzing data. To manipulate data, data must be collected from sources such as athletic events for various types of statistics to be created by the Departments of Public Safety and Transportation via police officers, by record companies to determine which record will be on top this week. Right now, we're going to visit with Courtney and Uvaldo, students measuring themselves for bridesmaid and groomsman outfits. The measurements they're taking will be our source of data for our objectives to be accomplished. Now let's take a look. Courtney's height, Uvaldo is measuring, is 169 centimeters. I'm entering the height in the L1 list since that is our independent variable list. Arm span for Courtney is 173 centimeters. Now Courtney will measure Uvaldo. Uvaldo's height will go in the L1 list. His arm span will go in the L2 list. L2 is a dependent variable list. His height is 167 centimeters. His arm span is arms up and out as straight as you can possibly get them. 148 centimeters. Now we're going to see Reginald and Beatrice take their measurements so that they can be properly outfitted for the wedding. Reginald is going to measure Beatrice's height first. So let's take a look. Beatrice's height will go in the L1 list and it is 164 centimeters. Her arm span is 146 centimeters. Now Beatrice will measure Reginald. Reginald's height will go in the L1 list, the independent variable list, and it is 187 centimeters. Now Beatrice will measure his arm span. Since his arm span is dependent on his eye height, the dependent variable information goes into the L2 list, and it is 189 centimeters. You might have noticed that I had already entered data into the list prior to entering the information from these young people. That's because in order to create an adequate line graph, scatter plot, etc., you must have at least 5 to 6 data points. Since we have 8 data points now, we can generate really good pictures on the graphing calculator. So let's get busy. With the data sets we have collected, we'll first of all create a scatter plot. A scatter plot is a graph that relates data of 2 different sets. We have that apparent in L1 and L2. L1 is where we recorded height. Height is our independent term, our independent variable. On height depends the arm span of the students that were measured. That's recorded in L2. The 2 sets of data are displayed in ordered pairs. To create a scatter plot on the graphing calculator, if you'll notice over the y equals are the words stat plot. Everything in yellow, of course, we hit the yellow key first and the appropriate key. That'll take us into our stat plot. To create a scatter plot, in plot 1, hit enter. Of course, hit enter to have that particular plot turned on, arrow down to type. The first type that's blinking now is called the scatter plot. I'll hit enter to highlight that. Since my data, my X list, is in L1 and my Y list is in L2, everything is appropriately set up now in order for a scatter plot to be generated. Therefore, for the graphing calculator to automatically give me a window range in which all of my data can appear, I'll use the keys zoom and then the number 9, hence creating a scatter plot of the data we collected of the heights and arm spans. The x-axis appears at the bottom, of course. The y-axis is the vertical axis. The different ordered pairs appear as the little blocks. To have a bar graph generated in the graphing calculator, the steps are similar. The only difference is in your graphing calculator type in the stat plot, you'll highlight the bar graph symbol instead of the scatter plot symbol. So let's take a look at the calculator and generate a bar graph. Second stat plot will take you back to the stat plot area. Since we have only stat plot 1 on, we're working out of it. Hit enter, arrow down to type, and if you'll notice, the third type on the top line is your bar graph symbol. Bring your highlighter over to that via the right arrow of your graphing calculator. Hit enter, and that will highlight the bar graph symbol. To have the calculator to generate a bar graph, again, in the appropriate window, zoom 9 will do it for you. Zoom 9 gives you the bar graph of the data of the arm lengths and heights. To see that information, if you'll hit trace, you'll see in the first bar we have arm lengths. This is out of L1. No, this is height. We have the heights between 112 and 130.75. There's one person in that category. Use the right arrow to trace over to the next one. The next category is from a minimum of 130.75 up to 149.75, but there are no heights in that category. The next category includes 149.5 to 168.25. There were 3 people in that category according to our list 1. 3 people between 168.25 and 187, and 1 person in the category of 187 through 205.75. From the bar graphs that reflected height, we can go back and also look at a bar graph to reflect the arm spans we collected. To do that is just a simple change in the stat plot area from our X list being L1 to our X list becoming L2. So let's change our X list and take a look at the bar graph for arm spans. Second stat plot takes you back into your plot area. We're working in plot 1. That's already highlighted. We'll arrow down to L1 and change that by hitting second, 2, and that gives us our arm span column now. Zoom 9 takes us to the bar graph that represents the arm spans. To take a look at the different number of people that are in the different categories of arm span, between 110 centimeters and 131.5 centimeters, we have 1 person. 2 people from 131.5 to 153. 2 people from 153 to 174.5. 2 people from 174.5 to 196. And 1 person from 196 centimeters to 217.5 centimeters. So now you know how to generate a bar graph in the graphing calculator. Now we'll use our data and have the graphing calculator generate what's called a line graph. A line graph is a graph that shows a set of data that changes over time. To To have our graphing calculator generate the line graph, though, that will look like a decent representation of the data we have, we can't graph it in the unsorted manner that it is. We've got numbers entered randomly. In order to have the graphing calculator to graph a decent looking line graph, we'll have to sort our numbers and have them in ascending order from smallest to largest. The graphing calculator will do that for you if you'll simply use the second list function that appears over the Stat button, arrow over to Ops. You'll see sort A and sort D as numbers 1 and 2. Sort A is fine. Therefore, we hit Enter. If information stacks like this in your graphing calculator, you'll have to clear it. Go back to second list again, arrow over to Ops, sort A, and put in the title of the list you want the calculator to sort. We want the calculator to sort L1 first, just by my choice. Therefore, we go second 1, that will enter L1, close the parenthesis, hit Enter. It says done when that's done. To save time, I'll go back now and go into second list, Ops, sort A. This time I'll tell it to sort L2, second 2. Close my paren, Enter. So now when I get back to my list and Stat Edit, my lists are in ascending order from smallest to largest. To have my graph to generate a line graph, I'll go back to second Stat Plot, enter Plot 1. The line graph is the second type of graph in the top column. I'll arrow down to Type, arrow over to Line Graph, hit Enter, and zoom 9. There it is. The line graph that represents the arm span, which is dependent on the height that's independent. These are the ordered pairs that are generated by the data we collected from the measurements of the young people. Now, from our line graph, we'll go back to our original set of data, and from there, we'll have the graphing calculator find what's called the line of best fit. So if you'll get your graphing calculators back in hand, get back to your original data, off we go. To create the line of best fit, again, we're working in statistics, so we'll go into our Stat menu. This time, we want the graphing calculator to calculate something, so you arrow over to Calculate. We want a linear regression. The standard mathematical linear regression that's used is at number 4, although there's another one in the graphing calculator at number 8 that's used basically by engineers. So we'll go back and use 4. Now the graphing calculator is asking you, where do you want the linear regression run from? Our information is where? In list 1 and list 2. So we'll tell it, go to list 1, find your comma just above your 7 key, and then calculator, go to list 2. After I tell my calculator where to go, I want to tell the calculator where to put the equation of the line it will generate when it's running the regression. Before I do anything, I'll go back to my y equals. And if there's anything in my y equals, as I have now, I'll simply clear that out. Because it's just my habit to enter a regression in y1. So I can always remember where it is. So I'll go back, I'll find my comma, put it in. Now, follow carefully. To have a y1 posted at the end of this regression command, you hit vars, arrow over to yvars with the right arrow. We're working with y equals, that symbolizes functions. We've got function highlighted at number 1. Therefore, we hit enter at number 1. And we have several choices of places to put the function in the y equals, my choice is number 1. So I'll simply hit enter since I already have that highlighted. Now my graphing calculator has all the commands it needs. Hopefully your calculator looks the same. To have the regression run, hit enter, and there it is. A value, this is the equation we're using, ax plus b. A is a constant, b is a constant. Our equation will have 0.85 or some rounded version, x, plus 22.27 or some rounded version of this number. You're interested in what the R factors are that are seen on the screen? These are called diagnostics. Some of you might not have those on your screen. Since I want everyone to be where I am, I want you to go second catalog just above the 0. If you'll notice when you go into a catalog, you're automatically in the alpha mode so that you can type letters. All of your letters are in green. Look below the math key and find the D. That takes you to the D section of the catalog. Arrow down until you find diagnostics. If your R factors did not appear on the screen, you want to go to diagnostics on and hit enter. Once diagnostics on appears on your screen, you hit enter again. The word done will come up when your diagnostics have been turned on. Now if you run the regression again, stat, calculate, for L1, comma, L2, comma, vars, y vars, 1, 1, enter. Everyone should have a screen that looks like this. The correlation coefficient tells how well the equation of best fit models the data. The value of R of the correlation coefficient is in the range between -1 and +1. The closer the R factor is to either -1 for lines that have a negative correlation and +1 for data that has a positive correlation, the better the fit. Our R factor is a positive 0.98, so we've got a pretty good fit in there. To get a picture of the linear regression line that fits the data that we have in L1 and L2, if you'll zoom 9 again, you'll see the data and the regression line come in. We've talked about our data having what's called a positive correlation. The positive correlation we found in our data needs a definition. So let's talk about not only the definition of positive correlation, but the different types of correlations that might be found and different types of real-world data that we'll come up with. First of all, positive correlation is a correlation when both sets of data increase together, as shown in your picture now. The way we know that this has a positive correlation is the trend line has a positive slope. If you'll notice, this line slopes up to the right. Therefore, hence, a positive correlation through our data. The next type of correlation is called a negative correlation. A negative correlation is when one set of data decreases as the other set of data decreases. If you'll notice here, as our x values get smaller, our y values increase. Y values increase and x values decrease, giving us a line with negative slope that slants down to the right, therefore showing a negative correlation. The last type of correlation that's available is called no correlation, where we simply have our data points so scattered that we cannot get a trend line to adequately fit through the data at any point. A trend line is a scatter plot that can be shown near the points. It shows a correlation between the two sets of data. In this scattered set of data, we cannot develop any type of correlation. Therefore, no trend line and no correlation. Now we want to take our data and evaluate it for the mean, the median, and the mode if it appears. We can have the graphing calculator to calculate those for us, but of course, you must understand what the mean, the median, and the mode are to make sure that the graphing calculator is giving you the appropriate information. The mean is simply the average of the data collected. The median is the middle value. The mode is the most frequently appearing value. To have the graphing calculator calculate the mean and median for you, if you'll go into Second, Stat, or List, arrow over to Math, you'll see at numbers 3 and 4 are mean and median. Mode is just the simple task of picking out the number that appears most frequently. To have the graphing calculator calculate the mean, arrow down to mean, hit enter. We don't want to start there. We want to go back to our home screen, second quit. Again, second list, arrow over to Math, 3, and mean will appear on your home screen. The graphing calculator is now asking you, what do you want the mean calculated on? Let's do our mean on the list of L1, find the median of L2. Therefore, we'd put in second L1, close the paren, hit enter, and that's the average of the heights that are listed in L1. To find the median, you'd go back to second list, arrow over to Math, 4 for median, and now the graphing calculator is asking you, median of what set of data? Let's do the median of L2. The middle term of L2 will be 171. We can't find mode. There is no mode in this set of data in either set, since there is not a number that appears more than once in either set. Your mode is the data item that occurs in a data set the greatest number of times. We do not have an entry in either list that fits that description. Now, from this exact same data, we've got a couple of new tricks to show you that I think you'll like. So let's take a look at the line plots from the data that we generated. This is the height of the young people that we measured. If you'll notice, we did not have any frequency repetitions. Therefore, in the actual line plot that would be generated from the data we have in our graphing calculator, the line plot would have a frequency of 1 at every height and at every arm span. If we create a line plot for the arm span, the same thing would happen. Therefore, actual line plots are not being generated. If you'll notice at the bottom, I have taken the liberty of creating what might be an actual line plot, having a frequency of 2 for 112 centimeters, 3 at 164, 1 at 167, 2 at 169, 3 at 173, 3 at 182, and 1 at 187. Now that we have collected and analyzed our data in some of the most standard ways, what do you think might happen if people's arm spans and heights were combined under the operations of addition and subtraction? Let's take a look at the concept of matrices and see what might happen when we do just that. Here you see matrices as it would appear in your textbook. You can get the graphing calculator to solve these matrices. Think about now, what would be the sum, or what would the actual sizes of the people be if we actually added these two heights together and these two arm spans together? What would the heights and arm spans be if we subtracted the two from each other? In your graphing calculator, if you'll go to Matrix, arrow over to Edit, you'll see that you can determine the size of your matrix. Go into Matrix 1, and we've got a 2 in here by 2 already. The matrices that we're working with are 2 columns and 2 rows. The numbers 112, enter, 110, enter, 164, enter, 146, enter, will determine matrix A. To get to matrix B, you go back to the matrix key, over to Edit with the right arrow, down to matrix B, and enter. If you'll notice, we already have a size of 2, enter, by 2, enter. If you need to change the size, you simply use the numbers. The numbers we need in matrix B are 167, 148, 168, and 169. Do you think the people will be larger or smaller when we add them? Let's take a look. Go back to your home screen. We've got matrix A. We want to add that to matrix B from names column and hit enter. You get your result. People have grown dramatically. When you subtract them, go back to matrix, names. We want to subtract the matrix B, A from matrix B, since our matrix A is the smallest. So we'll put in matrix B first. Minus matrix A. And you'll notice the people are a lot shorter. We have now covered all of the aspects of data gathering, collecting, displaying, and analyzation. We've talked about the scatter plot that can be generated, bar graphs and line graphs. We even ventured into independent and dependent variable concepts. We talked about the line of best fit or regression line that the graphing calculator can generate for you through your data that might have either a positive, negative, or no correlation at all, with the correlation being shown via the trend line. We talked about the modes of central tendency, the mean, median, and mode, line plot, and ventured into matrices. Now, if you'll go and measure your classmates, measure your family members, and see if your data will reveal the exact same or similar, at least, types of displays we've come up with today. It's been a pleasure working with you. Look forward to seeing you again. Bye-bye.